Welcome to our tutorial on using angular mates. We're going to pick up where we left off in our previous tutorial with the toy. In this tutorial, I'm going to use angular mates instead of distance mates to rotate the rotor. Let's exit Motion Study. Go back to our model. Currently, I have two mates for this rotor, coincident and distance. The distance mate is simply an offset between the rotor and this face. I'm going to click Mate. Let's right-click and clear selections. I'm going to create this mate in a way so that the initial rotor position is 0 degrees. And then it'll move to 90, 180, 270, and 360. It's easy to do this way, and it's less confusing for SolidWorks too. I'm going to select this face, and then this face. Now we select Angular Mates, enter the value at 0 degrees, Tab, OK. Next, I need to check the angle calculation clockwise. Basically, I increase the angle value, and the rotor moves in a clockwise direction. If that's not the case, simply check Flip Dimension. Let's go back and enter a value of 0, Tab. At this point, I'm ready to click OK, and OK. Let's return to the Motion Study tab. SolidWorks asks me if I want to update the time 0 keys back to valid positions. Let's click Yes. Previously, the key was red. Now it's blue. Let's highlight our key points and delete them. Next, expand the Mates branch. Here's my angular mate. Let's bring the time bar to the 1 second mark. Double-click on our angular mate. Let's move the slider to 90 degrees. OK. Let's drag our time bar to the 2 second mark. Double-click on our angular mate. Move the slider to 180. OK. Now let's move the time bar to second 3. Double-click on our angular mate. Slide up to 270 and click OK. Our last move is at the 4 second mark. We double-click and move the slider to 360. Let's click OK. Now let's calculate. Here is our preview. Everything seems fine. Let's press Stop. In a situation like this, it's important to watch for this particular problem. Let me double-click. 360, as you see, is actually equal to 0 degrees. But if I put in 0 and click OK, let's recalculate to see what happens. Let's press Stop. You can see that the rotor doesn't move consistently in one direction. Let's return the value to 360 degrees. Double-click. Move our slider up to 360 and click OK. Now let's run our calculation. Each time you make changes, you need to make sure you run the calculation. Now everything appears to run fine. Let's click Stop. For the initial position, if I'd used this face, for example, it would have made the initial angle 90 degrees. I'd need to have calculated starting from 90 degrees, then 180 here, 270 here, 360 here, and back to 90. Unfortunately, this probably would have confused SolidWorks, and we would have ended up with some similar inconsistency in our animation that we just saw when I changed the value from 360 to 0 degrees. You need to watch for these types of issues when using angular mates. In a situation like this, I could have simply used 2 key points at 0 and then 360 degrees and no intermediate points at all. but they are useful, for example, if I want the rotor to move at, let's say, different speeds. Of course, in order to match the piston movements, I need extra key points in the distance mates change bar. I'm going to skip this for now and click Calculate. You see now that the rotor moves slowly, and then it speeds up. However, the movement of the piston doesn't match the movement of the rotor right now. Let's click Stop, and this concludes our tutorial on using angular mates.